Welcome to our Inspiring Science Education webinar this afternoon. This is the first in a series of 3 webinars that we're organising over the next 2 months or so. And my name is Sally Reynolds. I'm going to be the moderator for our webinar this afternoon, where I'm delighted to welcome Chris North, Dr. Chris North from Cardiff University in the UK. Cardiff is one of our partners in the Inspiring Science Education project and is the person behind the Observing Challenge that has been launched recently on ISE. So let me tell you how we're going to organise this webinar. We have set aside an hour. So Chris is going to give a talk, first of all, about the Observing Challenge, how it works and the different tools. He's going to show us on screen how you can set up and how you can use it with your students. If you'd like to put in questions, comments, use the chat box. Hi Vince, good to see you joining us. Good to see Amani joining us from Berlin. Let us know where you are. It's nice to know where everybody is who's joined us this afternoon. And we will have time then for questions at the end of the session. From Thessaloniki, hi Nikolaos. We will have time at the end of the session to take questions from the group, from people who would like to put questions. But Chris and I also agreed that we'll stay on anyway. Once the session is over, we'll keep the webinar open if you want to stay on for some private discussion with Chris, if you have any particular issues that you'd like to raise with them. Hi Anna from Portugal. So just to remind you, for anybody who is unfamiliar with ISE, this is the portal and the website. We'll give you the links at the end and also the social media channels that you can use to stay in contact with all of the different innovations and opportunities that ISE is offering science teachers across Europe. We also have a special ISE Observing Challenge campaign going on at the moment, which Chris is going to be talking about this afternoon, of course. And we also wanted to remind you, if you haven't seen it already, that we're very, very keen to find out what people think of the ISE and the portal and the services that they're offered. So we have a fairly large survey going on at the moment where we really would like to hear from you about that. So we'll give you that link again at the end. And in fact, thanks Alberto, you're putting it into the chat for people. So even if you can only fill part of the survey in, please do let us know what you think of ISE so we can make it all better for you in the future. So I'll shut up, switch off my camera and hand the floor over to Chris.
Okay, thanks very much. I assume everyone can hear me okay. If you can't, then someone type something in the chat very quickly and I'll try and do something. Excellent. So as Sally said, I'm going to talk about the ISE Observing Challenge, which we're running as part of the Inspiring Science Education project for the next, I guess it's about 5 weeks left of the challenge, so until the end of June, 30th of June is the deadline. It's here in Cardiff. We've been coordinating it along with other colleagues in Inspiring Science Education, Galileo Teacher Training Project, for example. And the telescope time that is used for this is all from Las Cumbres Observatory Global Telescope Network, LCOGT for short. So I'll probably refer to them as LCOGT because it's less of a mouthful than their full name. So there's a presentation on screen. There's also a link down in the bottom left that I believe you can click on if you want to browse, look at it locally. You can download it. It's about 20 megabytes. So there's a few pictures in there, which is why it's so big. But I'll show it on screen as well, and you should be able to follow along. So what is the Observing Challenge? As I mentioned, you have to participate by the 30th of June this year. The challenge is to use Messier Bingo, of which I'll discuss more shortly, and then observe an object with professional telescopes. Again, I'll talk about Las Cumbres Observatory's Global Telescope Network shortly. And then there's a very key thing, which is once you've done this, you have to submit an entry on a Google form for us to know what you're doing. Hi Rosa, great to see you. Rosa's also been one of the key pillars behind this challenge as well. What you get for this, as well as using our resource, Messier Bingo, and then the telescope time, is if you submit your entry on the Google form, you will receive a personalised poster with the image of the object you've taken, and then that will be sent to you for your class to put on the wall or whatever you'd like to do with it. So Alberto has just posted up the link to observing challenge. There's the link is the same as the bottom of this slide. We've got a sort of shortened URL to make it a little bit easier to remember. There are two ways of doing it. If you're in Inspiring Science Education, if you're registered, then you can join the community of the ISE Observing Challenge, which is on that link. Clone the demonstrator and then deliver it to your class. What you get there is you get all the things that you can do with a demonstrator in Inspiring Science Education. You can see how your students have done, you can monitor their assessment, you can see how they respond to the questions. Again, I'll talk a little bit more about that shortly. If you're not in Inspiring Science Education, then there's one easy way around that, of course, is to register for Inspiring Science Education. You can join the community straight away and start doing it. All that requires is, again, I'll show you the web page shortly, but you need to click on a register link and then join the community, and it'll just wait for approval. So someone will see the email probably very shortly and then click OK, and you'll be in. To do it without joining ISE, then you can just direct your students to a common delivery link. So there's a link there, which again, these are all on more information on the page which Alberto's linked to. I will show you that in a second as well. And that means your students can run it. Your students can do the activity, and the catch is you can't see their assessment thing. So in some ways it's easier to just send one link out, but you can't try the assessment. So we would encourage you to use the first method, to clone the demonstrator and deliver it to your class that way, but there is a sort of a shortcut if you'd like to do it with the caveats that you don't see everything. So in terms of the link and the website, hi, I can see we've got people joining from all over Europe, so it's great to see people there, so welcome all. The website for the ISE 2016 Observing Challenge is, I've just switched to the slide for now, it's just a screenshot, it's not a live view. And you can see, I think if I enable pointer, there we go. So you can see a few links. This is a screenshot from when I was logged in to Inspiring Science Education. So there is a leave button. I could leave the community should I wish. I clearly won't be doing that. If you're not registered for Inspiring Science Education, then there will be a register button up at the top right of your screen, and you can register and then search for this community to join. If you're already a member of Inspiring Science Education, if you have an account, you will see a join button where this screenshot says leave, and you can just join, and again that you'll be able to join in. All the information I just told you is on this page here, slightly more verbose than was in the slide, but the links there are active when you go there. So I will type in the link again. So there we go. So that is the shortened URL. So if you go to that link, then that will take you to that website. There are a couple of other versions as well. Now, there's one in Portuguese, there's one in Italian. If you're in those countries, there's a similar community, and then the resources are also translated as well. There may be, I'm not aware of other languages at the moment, but some of those may crop up. If you have a particular request for one, then you can get in touch with your Inspiring Science Education national coordinator, and they may be able to prepare something for you. So yeah, there is Portuguese, Rosa, yes, I've seen that. There's also, as I said, I think there's Italian as well. So on to what this is all about. This is all about using the observing network of Las Cumbres Observatory, their global telescope network, so LCOGT. So LCOGT are a company, they're a US company, but they're international in their reach, and this is a map of the world showing where their telescopes are. And the ones, they have various telescopes. There are so two very big telescopes that this isn't involved with. There's two 2-meter diameter telescopes. For those unfamiliar, the size of a telescope, the diameter of the telescope essentially measures, or it tells you what resolution you can get, but also how faint an object you could see. So the bigger your telescope, the fainter the objects you see, and the faster you can take images of brighter objects as well. So there's some 2-meter telescopes, one in Hawaii, one in Siding Spring in eastern Australia, just a little bit north of Sydney. There are also, as well as that, some 1-meter telescopes. There are in Cerro, down in Chile, Cerro Tololo, I think it is, in Sutherland in South Africa, and McDonald in the US, I think one in Siding Spring, a cluster of telescopes in each of those places. So those are 1 meter diameter telescopes. They are much bigger than any amateur telescope you're likely to get. If you have amateur astronomers that you're friends with, they will have telescopes, but they're unlikely to be a meter in diameter. There's another network of smaller telescopes being rolled out at the moment as well, but they're not online as part of this. What we're using as part of this challenge is the 1 meter network of telescopes. So the advantage of having a global network is that although it might be daytime where you are, for example, when you're in your school classroom, it's going to be 2 o'clock in the afternoon or something, a telescope around the other side of the world will have darkness. So it's night time, the telescope can observe. There's also a little bit of redundancy if there's bad weather. So for example, if McDonald in the US has bad weather, then it may be that Hawaii has good weather or Siding Spring has good weather, and you can observe with one of those as well. And there's almost 24-hour coverage where one telescope can see the sky. It's dark somewhere. I think there's about a 1/2 hour window or something where they don't quite have full coverage, but it's pretty thorough across the 24 hours. So what do we do with this? Well, we use Messier Bingo. Now, an easy thing for me to do might be for me to switch to showing you the Messier Bingo website. So what in practice, this is brilliant, thank you. So that is the website of Messier Bingo. If you go to, there are links at the end of this, so don't worry about scribbling down links. I've got a few pages there. They're in the presentation as well. And so lcogt.net/education/Messier Bingo. This is essentially the teachers page of this. What you see here is instructions for how to run that in a class. What happens is you give your students a printout of a bingo card. So each bingo card has 9 slides on it. I think if I switch back to my presentation, I have a slide of it. I'll skip through to the right slide. There we go. So this is a picture of a bingo card that you can download and print out. You could obviously do your own bingo cards if you wanted. These have the advantage of having pictures on them. So there are 9 objects on this bingo card. The pictures shown are actual objects taken with the Las Cumbres Observatory network, and they're all Messier objects. Who was Charles Messier? Let me smoothly slip back through my presentation. Charles Messier was an astronomer who lived in the 18th and 19th century. He was a French astronomer, and he was on the search for comets. And one of the frustrating things about comets, if you've ever tried to look for a comet in the sky, is that they are fuzzy blobs. And there are lots of other things in the sky that are also fuzzy blobs. And so what Charles Messier did is he made a catalogue of about 110 objects in his catalogue. I don't believe he catalogued all of them. There's a little bit of controversy about who exactly completed the catalogue, but the Messier catalogue contains 100 objects that are not comets. They are galaxies, they are star clusters, that kind of thing. So what are these? There is, for the teachers to download, a presentation with what I'll show you now in. So this is on the LCO website. You can download this presentation. The PowerPoint file, I believe, is available for you to download from here as well. So feel free to take that and use it. The types of objects that we see are nebulae. So nebulae are stars of gas and dust where stars are currently forming. You can see this is a picture of Messier 42, M42 for short. It's the Orion Nebula. Some of you may have seen that through binoculars in the Sword of Orion. You can see right in the centre there's the little trapezium cluster of 4 stars in a trapezium shape. There's a very young, very hot stars forming right in the centre of this massive cloud of gas and dust. It's a few dozen light years across, getting on for 100 light years across, and it's 1500 light years away in the constellation of Orion. So that's the kind of object we see. You see this fuzzy glow. The gas is being lit up by the stars in the centre and being energized, ionized, and emitting light as a result of that. There are other types of nebulae as well. This is a planetary nebula. This is Messier 27, M27, which is also called the dumbbell nebula. You can see it's got these 2 lobes, much like a dumbbell that you might use in the gym, for example. This is a planetary nebula, nothing to do with planets at all, in fact. when you see them through very low magnification, then they look like a little round disk, which is what planets look like. That's essentially how they got their name. But they are much, much, much bigger than that. Right in the centre of this planetary nebula, you might be able to see a tiny little white dot. That tiny little white dot is an aged dead star, essentially, a dying star, right in the centre. And as stars reach the end of their life, they puff off their outer layers, and those outer layers have expanded outwards through space over thousands, hundreds of thousands of years. I forget exactly how old this particular object is, but they create these wonderful shapes on the sky, and there are lots of other objects out there that have amazing patterns in them as well that you can see. So astronomers have a bit of a field day with trying to observe these things. So planetary nebula is whereas what I just showed you, things like the Orion Nebula are a star-forming nebula where stars are being born. This is the death of a star. And there's then even more extreme stars. So the planetary nebula is what happens when a fairly massive star, or a star much like our Sun, which is a common or garden star, your average star in the galaxy, sheds its outer layers. When a much more massive star than the Sun explodes, so something, say, 8 times the mass of the Sun, up to 20, 30 times the mass of the Sun, probably even higher, then when they die, they don't just pop off their outer layers and fade into this dead remnant, this dead husk of a star right in the centre. What they do is they explode in something called a supernova. The nuclear fusion in the centre of the star stops, the star collapses, rebounds off the core, and that immense energy explodes the star outwards in this hugely violent explosions. The picture shown here is Messier 1, the Crab Nebula. It's in the constellation of Taurus. You need a reasonably sized telescope to see it. It's the remnants of a star that exploded in the 11th century, observed by Chinese and Middle Eastern astronomers. It's in their records as having having exploded and being seen to explode. So this is a 1,000-year-old, or thereabouts, remnant of an exploded star that was much more massive than our Sun is. So you see those as these fuzzy blobs in the sky as well. So those are 3 different objects that are gas, and well, what you're seeing here mostly is gas. There is dust there as well, but there's gas in these objects that is diffuse, and you're seeing with these telescopes. But you also see stars that are normal or everyday stars. They're not stars forming, they're not stars dying. These are clusters of stars. Stars, almost all stars we think, are born in clusters, in groups. And stars such as this one, Messier 47, or clusters, sorry, such as this one called Messier 47, it's called an open cluster because it will gradually dissipate. Stars will gradually drift apart. It's likely that our Sun formed in a cluster like this about 4.5–5 billion years ago. And as these stars drift away, the cluster will disperse, but that takes millions of years. So these are here to stay for a little while. So we see clusters of stars that you see as this smattering of stars over the image, and again, sometimes you can try and see patterns in them. And then globular clusters as well. Globular clusters are huge collections of stars, hundreds of thousands, sometimes millions of stars, all in one ball. And the reason they're ball-shaped is that there's enough stars there for gravity to collapse this thing, or to pull this thing into a sphere, essentially. Much as gravity pulls stars and planets into spheres, it can pull these clusters, these globular clusters, into spheres as well. Some of these are towards the centre of our galaxy, some are in the halo that surrounds our galaxy as well. But there are a bunch of these objects there as well. And actually there's quite a lot of star clusters. Although these look through this telescope like individual stars, through a smaller telescope, such as ones Charles Messier had in the 18th and 19th century, they do look like fuzzy blobs. So you could easily mistake them for a comet if you weren't looking carefully or didn't have this catalogue, for example. And then finally you get to a spiral to galaxies rather. So these are galaxies much like our own Milky Way, and there are several types of galaxy out there. This is Messier 66. This is one of 3 galaxies in the constellation of Leo. It's very close to one called Messier 65 as well. This is a spiral galaxy. You can see it's got these spiral arms looping outwards, and this one is what we call a barred spiral galaxy. It's got this bar across the centre. And you can really see these dark dust lanes. Those are the regions where the gas and the dust is collecting together. That's actually where stars are being born, inside those dusty cocoons. And the bright young blue stars around here are the young stars that we're seeing shining brightly. And then if we you get much bigger galaxies typically, called elliptical galaxies, Messier 60 in this case. And this is an elliptical ball of galaxies, maybe say a rugby ball shaped thing, not normally perfectly spherical, and these are typically much bigger galaxies. They don't have as much structure, the images aren't quite as striking as the spiral galaxies. And then there are now on the Messier catalogue you get irregular galaxies as well. So each student, there's a pack of 30 of these bingo cards to download. You can give each student a bingo card, and then what happens is you play bingo. You have a tombola, an online tombola. So let me start sharing my screen again, which I think is this one I want to share. There we go. So this is the Messier Bingo screen, and there is a link down there somewhere for launch the Messier Bingo random image tombola. So here's one I made earlier. There's a page here. When you go there, you get two options. One is you can just play it, but the other is that you sign in, and you sign in, and that gives you the opportunity to take pictures, to take images with this network of telescopes, and I'll show you how that works. So you sign in. You need a username and password. Now, for the purpose of this challenge until the 30th of June, we have a username and password that teachers can use. The username, this is detailed in the lesson plan, so again, don't remember if you forget this or don't write it down, but our ISE UK password, so Astro, as you can see, I've logged in here before. There we go, and then the password is robotic. Those are detailed in the lesson plan, so those are not exactly a secret necessarily. But what we ask is that because this is a username and password for everyone to use, you use this once, you take your observation with your class, and then when you've done that, then if you want to do more, then you can join the things like the Galileo teacher training program. If you're in the UK, you can join the Forks Telescope project, for example, and get your own username and password. That is free. You don't have to pay anything for that, but you need to contact the relevant people. Again, details are on the website. So I will log in. I'll find it, can remember the password. There we go. And this is then what you see. So you get the students are instructed to get their bingo card and mark it each time one of their objects appears. I'll see Alberto has put the link up to the website that I was just showing. Thank you. So the students get their bingo card and they start to mark it. As the teacher, you might be presenting this on a projector, for example. You click next image and you start off the tombola. And this is a randomized selection of images. Here we go with Messier 58. Which you can see is a lovely barred spiral galaxy. One of the things you can do is turn the information off. Right, so you can turn off that little panel if you want, and as they're going through, they see this is a barred spiral galaxy. It's obviously useful. They need the information to check off their number. But the reason I say you can turn it off is there's other little things you can do if you want to make it a bit more engaging. You can say to them, well, we're going through, you're ticking off your images. When someone gets a line, so 3 in a row, 3 in a column, or whatever, or maybe the first 3, is that you say, right, in that case I'm going to turn off the information and ask you, I'll do a next image and say to you, right, what kind of object is that? And if you've done the introduction of the different kinds of objects, they should identify. This looks to me like an open cluster. I could of course have done a poll on the Spreed service and seen what people thought it was, but I would say that was an open cluster. If the student has got it right, then you turn it on, and indeed, that's lucky, I was right, it's an open cluster, and they get a sweet or whatever you want to give them as a small prize, and then carry on going. You may not want to wait until someone gets all 9. That could take a little while, but you might want to wait until someone's got all 3, or someone's got 6 of them, or something. You can go on as long as you want in your lesson until an end point, and you can carry on going through it. And there are some amazing images in here. Look, it's M83, the Southern Pinwheel Galaxy. I could sit here all day and look at these images. The Northern Pinwheel Galaxy, Messier 101. That's a remarkable galaxy to look at. So I could look at this all day. I won't. Don't worry. But what you can then do is say, well, you can see there's a green button down here, which is take your own picture, and that means that you can, as a class, agree on what you want to take a picture of. You may wish to say, right then class, what type of object do you want to observe? Or you may say, which object do you want to observe? So what you can do is you can go through and say, fine, we want to observe a spiral galaxy. And as you go through, you wait till you find one you want to observe, or find an object you want to observe. as you're going through. Say, oh, M82, it's a galaxy. That's a good choice. And then you take your own picture, and it says, do you want to observe an image to be taken in the next week by LCOGT? And you say, yes, please. So it sends your request to Serral, which is the name of the robot or the scheduler behind this system. And what happens is the system now has your observation in its scheduling. It's figuring out when to go and observe it, which telescopes it can be seen from. This, for example, is in the northern hemisphere, so it's probably going to be the North American 1 meter telescope that's going to observe it, and it will try and do that in the next week when it's cleared. So if I go back to the presentation, let's see where we are. So I've shown you these things already. When you've done that and you've said you want to observe that telescope, sorry, that object with the telescopes, that will happen at some point in the next week. The next thing to do is, again, there's a link to this Google form. To get your poster when your image is observed, you must fill in this Google form so we know who's done it. Again, the Portuguese and Italian versions, there are links to this from the lesson and from the community. So you can get there, or you can fill in the English version. But we need that to be able to know that you've done it and send you the poster. It's got a few other details about what object you observed and so on. So when you've gone through with this, then what we do is we direct you to the LCOGT on Sky service. So again, if I do my screen sharing and share this window again, there we go. So this is the LCOGT's on Sky service, and this is when you first log in as the same username and password you used before, ise@astro.cf.ac.uk and password robotic. Yeah, you log in and you see all of these things, and there are some buttons here to look at. You can view your submitted observations, for example. And what did I click that? There we go. So here's our submitted observations. Now you can see that M82, the one I observed, that was put in there at 14:25 GMT. Universal UTC Universal Time is what these are noted in. So it's not necessarily your time zone. That's my observation. It's got a black outline. It hasn't been observed yet. Neither has M88. It may have been cloudy and they tried to observe it. It will then try again in another day. But the other day I did M65, Messier 65, which is this galaxy here, and I can click on the various images. I can click on the M65 and see what happened when it observed it. It observed it took 10 minutes. It was some 135-second exposure, so that's 2 and a bit minutes, in 3 different colours, essentially red, green and blue. I can click on an image and this will take me to the image thing. So here we go, we can, oh, where's it gone? No, that's not clicking. Let me go back to my my home and do it the other way. So if I view all my observations, this is obviously having to ask a big server for all the images. Here we go, and then I can click on the image and then see more information. So if I click on that, there we go. This was M65, and hopefully it's going to load. The service is just waiting. There we go. So I must have clicked on the other image. M96. So here's an image of M96. You can see the JPEG and the FITS file, and you can download the image. If you want to do analysis of it, you can look at the FITS file. If you really wanted to, you can look at the JPEG as well, just to get the image. And that's the kind of thing that will be on your poster. We may be able to make you a 3-color image to make you a colourful image, although most objects turn out kind of grey anyway in astronomy. So that's taking an observation. That's how that works. As I say, instructions for all of that are in the lesson plan. Yes, I can see there's some questions that I've not been reading. So if I scan quickly back through, yeah, I'll answer any detailed questions at the end. But yes, the access to the image, you can, when you go
Rose is doing a very good job in answering them, Chris.
You
so don't worry.
Oh, excellent! Thank you, Rosa. So you can go in and access the images from the LCOGT on Sky service using that username and password, and you can just get access to these images and download them. You can see the kind of things that other people have observed as well. Now I believe I'm still sharing my browser screen, so I can show you the lesson. So this is the lesson that we planned. This is a preview of the lesson that students are asked to work through. So for example, you may want to spend 10 minutes discussing some of the astronomical objects with the class and how you might study them, and there are some problem solving questions to ask your students. This is the teacher's view, so there are the teacher gets to see which are the low, medium and high answers. Those are all correct, but some are lower, medium and higher level answers for students to select from. As you go through, the students, and that's part of the Inspiring Science Education portal, of the scheme behind these learning scenarios. A little bit of introduction to LCOGT and their robotic telescopes. So there's a very pretty picture of one. I believe this was being tested in a car park in California, so this is not a good site for observing, and it looks like there's a car park directly behind it with some street lights. This isn't where those are currently sited, this is one of the test ones. And as the teacher, again in this grey box at the bottom, you can see the details for that. And again, as noted here, those username and passwords are valid until the 30th of June. After that, you'll need an account, but until then, you can participate. And then if we plan, there's planning the investigation. So this is where students can work through the Messier catalogue. You may want to chat to them about the different objects. These are some of the images that we showed before. Again, you could show them the and the images appear below as well. I must remove them. And then analysis and interpretation section is actually playing the bingo to learn to apply what they've learned. As I say, you give them little quizzes about the different objects, and they can answer those as well. And this is down here the requirements that you'll need to do to be able to run it. You need, for example, to have printed out your bingo cards, for example, and then there's instructions as we talked about. And then there's a few ideas about what you might observe as a class. As I say, please don't click every object as you go through. Just pick one object as a class. If you get your own account on LCOGT or through Galileo's Teacher Training Program or the Forks Telescope project here in the UK, then you will be assigned a certain amount of time, and you can actually observe your own objects. So when I showed you if I go to my LCOGT on Sky, so I showed you this page here, there's a request observations. You can actually pick objects to observe. So if I go back to my presentation, I've shown you that on screen. I've shown you the images to use and where to click on and how to get the images. And then this is an example of a poster we might send you, for example, with your pictures in. And you can, as I said, if you don't want to observe a Messier object, if you want to observe a different object, or if a student says, but I really want to observe M101, and you can't be bothered to go through and click through Messier Bingo until the random image sorter comes up with the object you want, then you can go and request a specific object. If you do that, it asks you when do you want the image to be taken. Do you want it in the next week, in the next 2 weeks, in the next 24 hours? I would advise doing 1 week. If you do 24 hours, then if it's then cloudy, for example, your observation just won't happen, which would be a shame. So give it a week to give it a chance to not be cloudy at certain telescopes, and so on. And when you select an object to observe, you get a list of example objects you might want to observe. You can type in a target name if there's a specific thing you want. Bear in mind, these are very, very big telescopes. You cannot point it at the moon. You can't point it at bright planets such as Jupiter and Saturn, because they are too bright. They don't permanently damage the detector, but they don't produce good images. So, but you can point at any of these objects here, and then you get your observation log. This is set up to then observe in the scheduler. And then, as I showed you this screen earlier as well. So that's all I kind of have to say about that as the little presentation. There's some links here as well to the different things. I can see Alberto's put in a couple of links down in there. And if you have any questions about this, then I'd be more than happy to take them now. I know we've got some time left, and I can try and answer any queries there might be.
Chris, thanks very much. It's really, really very interesting altogether, and I'm sure people have some questions for you. But at the same time, we're also going to, Rosa's connected as well too, so she has a headset. So we've just changed her status to moderator, so we should be able to see her and hear her soon. She will probably have to activate her camera and her microphone up on the top to the right of where it says interrupt meeting. There she is. Great, Rosa.
Okay.
Good to have you with us as well. Yep, we hear you fine.
Good. Perfect.
So it's nice to have both of you now because, as Chris mentioned at the beginning, of course, you're deeply involved in this initiative as well. So let's see if people have got questions and ideas and suggestions. There was one very direct question I saw there about, I think everything was answered by Rosa so far, apart from the question about the filters. I don't know whether you saw that. That was a question from Ramulda from Lithuania, as far as I know. Is it possible to ask the observations in other filters, for example, UBV? Chris, that's a question for you, I think. Can't hear you.
Yes, so with this system you can request filters. If you go in and select your own observation, so the easiest thing for me to do is very briefly possibly just to do screen sharing and see if this works again. Let's share that window. So this is the LCOGT page again. I can request an observation, and just while there we go, I'll say I want it in the next week. I will add an observation, and I can pick an object. Let's observe a group of galaxies, HCG 30. Actually, that's not the one for a group. Let's do a planetary nebula, NGC 7293, and this is by default is a 3-color image. I can uncheck that and select a filter instead, and any of these filters. Now they're not all available on all the telescopes, so you do have to be a little bit careful. There is information about that on the LCOGT website, but you can essentially pick, for example, H beta or Bessel I, different filters if you want. By default, your images will come through if you just use Messier Bingo, or you use the standard 3-color image you can see here. You'll get red, green and blue, which in astronomy terms is the R, the V and the B filters. Does that answer the question? There we are. Yes. Does that answer the question that was asked?
I think so. Let us know if that doesn't fully cover what the question was. So now is your chance. We have lots of people who are teachers taking part this afternoon who are going to go and do this. Please let us know if you have any questions, anything you're not sure about, anything that's bothering you about trying this out. We're really keen to have as many people, and we have people from all over Europe taking part this afternoon, and so we're really keen to have you take part in this. It's a question for both of you, really, I suppose. Is this targeted any specific age group, do you think? Rosa, maybe
if I can answer that, Chris? No, it doesn't. I've been using the LCOGT telescopes with children from primary to secondary school in public events, so it goes from 8 months to 100 years.
I like the 8 months idea.
It's the time they can sit down by themselves. They can already choose things on a tablet.
Yeah. I can imagine it must be really, really engaging, though, for students to be able to identify something themselves, to get a picture back of it, to know that it's taken place. Is it something that you've seen really encourage students to take more of an interest in astronomy, do you think, Chris?
I think it is. The ability to be able to go and use... Oh, I think there might be a slight delay. Yes, students get interested in all this stuff when they can make the observations themselves. They can see it, and you can, for the older students, you can add stuff. You can add other features. For example, ask them to go and look at it in Planetary software such as Stellarium. You can do a lot more with them to add to the lesson as well, to investigate it a bit more. And go into more depth, but being able to make these observations with telescopes that you simply don't get access to otherwise. I mean, these are the telescopes cost hundreds of thousands of pounds each to build and maintain. So these are expensive pieces of kit that clearly a school does not have access to, and many universities don't have access to their own. We use international.
I suppose that the begs the question: how do we get our hands on the 2-meter ones? You're talking about using the 1-meter ones, but the 2-meter ones must be even more fun to use. So, is it possible to access those at all?
So those can be accessed through, depending on your account with LCOGT. So if you go, Rosa, does Galileo teacher training project give you 2-meter telescopes?
Yes, it does, but what we try to do is to use the smaller ones for starting and engaging the students when you're doing your pretty pictures and things like that, and use the 2-meter for research purposes. We have this project called, for instance, Black Holes in My School, where we are inviting children to observe black hole candidates, compact objects, and do real research, or observe asteroids and do follow up on asteroids that they discover. So we tend to use the 2 meters more for that, and the rest of the network for the pretty pictures. And just to add to what Sally and Chris were saying, when I began my career as an outreach person, you went in a school with a pretty picture, a Hubble picture, everybody would go like, wow. Nowadays the reaction is not quite the same, because children are bombarded by this through the internet every day. So now it's the time to put the images in their hands. So say, well, so you know that picture of Hubble that you like so much, now you can have yours, and engage them in using the picture. So this is the tool that the magic tool that all teachers should know how to use.
Indeed, indeed. And of the teachers who are taking part this afternoon, I presume lots of them have already used this, because I know that we have some quite experienced teachers with us. It would be very nice to know in the chat if you have, what kind of experience you've had with this. Has there been, has the wow factor really worked in terms of being able to identify your own images that you wanted to capture? We have people from different parts of Europe. It would be really nice to know that. Alvaro, I see you're saying involving students with scientific projects as SN studies. What is that, Rosa? Research studies?
I don't know.
Okay,
I don't know
Alvaro, maybe.
Studies.
Supernova.
Supernova study. Alvaro did an amazing job with the team of Folks Telescope, studying and following up supernovas. They are actually going to publish a paper, and probably Alvaro and his students are going to be in the paper list of authors.
And these are secondary school students?
I don't know that, Alvaro. I think his club has not only secondary, but I'm not 100% sure.
Yeah, must have been a really amazing experience to be able to do that. I think you're right, though. Secondary school, great, Alvaro. Very interesting to know that you've been doing that. So you're an experienced person.
We have a case in Portugal also of another teacher that is from our network who has been following up an asteroid, and I know she has students from 7th grade to 12th grade.
Wow, yeah, yeah. And so they basically feel they own that asteroid now, I guess, do they?
Yes. Yeah, kind of.
And there's kind of enough up in the sky, I think, so that every school, every student can have their own, can feel a sense of ownership in terms of what's going on up there. So
we have 37 asteroids discovered by Portuguese students.
Wow, it's impressive. Chris, can you compare? How do UK students do?
I don't know the number that UK students have discovered, but Rosa's right that it is possible with this to really go very deep in school lessons. You can take this to almost any depth. These are professional quality telescopes. Professional astronomers use these to do astronomy research on all sorts of things, the kind of things that these school students are doing. So it might be looking at supernovae, it might be looking at black holes, it might be looking at discovering asteroids, for example. With the discovering asteroids, it might be looking at a patch of sky and see something moving. You might be trying to characterize one that's been spotted and you're trying to help with observations, and that means you have to be quite careful in pointing the telescope in the right place. So it's a more complex thing, but again, the students can really get involved with what's going on there to do it in greater depth. So there's a huge range of things you can do, from the very simple Messier Bingo, here's a pretty thing, take a picture, type of thing, which is the kind of the lowest level, if you like, of the engagement, up to these very, very deep engagements that if you discover you like this tool and you find it useful, then you can go much deeper with students as well. And the students may indeed then drive it themselves. That's one of the great things about this stuff. The students can think up the things they want to do, they want to observe, which really is them taking the bull by the horns and driving their own lesson.
Let me just add something here. The whole repository of data is available. So there are plenty of schools that they go there, they take a pretty picture, and that's it. They don't analyze the pictures. We have a repository of several years of images. Anyone can go there, download this time series of a particular object, and maybe they will find a supernova or find asteroids, as Chris was saying, or something that changed in the particular object through time. So there's a lot of science to be done with the repository of Las Cumbres, really a lot of science. And
real science.
Let me just answer. I saw some comments here from Nicolaus and Álvaro. We know that this is exam time in many countries in Europe. Still, this is not something heavy. This is fun. So I am pretty sure that all of you have the last week of classrooms where you were engaging in some fun activity with the students. I mean, I consider this really a very nice activity. If I was a student, I would love to play with this bingo. So I think you still have the opportunity. Actually, in Portugal, I know there are already 10 or 15 schools in line to promote this in the last school week. So maybe you can consider this as a prize to the students in the last moment they are with you guys, so they depart to vacation with a good taste of astronomy.
I was going to say that, students need to relax as well from all the stress of exams. So come on, let's give them some fun thing to do. And I think playing bingo like this is not a bad thing to be doing. So we take the points, Nicolaus and Alvaro, but we still think that you can still be doing something with this over the next couple of weeks. So thanks, Nicolaus.
Even after that, it's worth saying that in September all these things will still be there. The challenge will have ended. That global that single sign-on account won't be valid anymore, but you can get an account through Galileo Teacher Training Project, which is what Rosa is very much involved with, and then do your own observations that way. You can do exactly what you've just described, but using your own LCOGT or Galileo Teacher Training Project account. I don't know whether Rosa has anything to comment on that.
No, just let me. I'll write down to you. Writing and talking is not my best dividing brain skill, but I will put here the website of the Galileo Teacher Training Program and my email. Please, you can contact me at any time. I am pretty sure other challenges are going to come and other opportunities. And as Chris said, the telescope and the demonstrator is going to be there, and you can always use. But I think this challenge is fun because it's lots of people together, and you get a poster, which is not something that LCO is willing to do all the time. So I think it's a good opportunity to take this moment, and to me it feels like we're giving you opportunity to give a big cheers to the whole Inspiring Science community, which was a huge community this year. We are almost reaching 10,000 students that used the demonstrators, which is not a small number at all. So it would be really nice to have this cheers moment with all of you.
How big is the poster? Good size, Chris?
The poster will send out. It will be sent out via your national coordinators, but will probably be A4 or A3. So it's not massive, mainly for the logistics of posting these things out. But it should be printed nicely.
Well, the fact is yours and your observation and your class did it. I think that's obviously where it's nice. Unless anybody has any questions, I'm just going to bring this to an end, but we'll stay on live, so for any casual conversations, if people want to stay on afterwards, and we can try switching on a few microphones as well if people would like to do that. But for the formal part of the session this afternoon, I just wanted to, Alberto's going to put back up, I think, the closing slides for me, just to say that we will be having, we're running 3 webinars between now and July. So this is to remind you where the Observing Challenge information is on the project website. It's to remind you about the survey, which is really, really important to us. As I said at the beginning, we're very, very keen to find out from people what they think of ISE, how they'd like to see it improved. It's very much part of how the project is and how we work, to try and work on feedback and to try and improve. So please give us your feedback if you can, and the link is there for it. This is when our next webinars will be. So Rosa is going to lead one for us on the light pollution scenario on the 22nd of June, and then we're going to have one which takes us actually out of Europe, which is really interesting. We're going to have Alan Gould joining us from UC Berkeley from NASA, talking on the Wednesday the 13th of July. So we have a great lineup of 2 more webinars, so put them in your diary. We will remind everybody who has already registered for today. I will also make available the recording of today and the slides from today as well. Don't forget our Facebook page, Twitter, YouTube channel and SlideShare account from Inspiring Science, which Alberto is kindly putting into the chat for us as well. So, as I say, we're going to close the formal part of the webinar now. So thank you all very much. Thanks, Chris. Great job switching between the screen sharing and the slides, which was great. Thank you so much. So bye-bye to everybody who wants to leave now.